Okay, we have about 17 people now. And let me explain to you the whole practical aspect of what we want to do, right? We want to be able to, our goal is we have the month of August, right? And we have the month of September. Okay. So, what are the things we want to cover? We want to cover networking. Okay. That is for sure. Now, in Linux, a lot of people just teach you networking for Linux, which, honest to God, is probably like 1/10 of entire networking technology, which is not good. We don't want that because we do want you to learn networking. Why? So that when somebody reads your resume and when you're presenting yourself, you can open more doors. Our goal is we want you to be able to leverage through Linux uh, an ecosystem, right? If an opportunity for troubleshooting in networking comes up, uh, you are good to go there. You can take a dive into that. If something comes up with uh, site reliability, right? SR, you are able to handle that, right? So that's why we are building this ecosystem. You know, and at the end, I'm going to consolidate all the presentation, and we'll spend 2 days to go through the presentation to review all our material, a week to review and to put you on and come on board and evaluate you. How well can you really do everything that you know? And have a discussion, open discussion with everybody, right? So we are not teaching a class, right? Even though you have to call it a class, we are building capacity. We have said that from day one. Capacity is what is important. I'm gonna send out some uh, spreadsheets once I talk to Bilal. We can get all your emails. So basically, we want to bring you into our company called Next Ventures, like the venture.com. Bilal is fixing that website right now. You can even see it right now if you want to. But um, and nextventure.com is a combination of NIT Academy, right, and all that. This nextventure.com is connected to LinkedIn at the moment. Okay, LinkedIn. It's an old company. It's 20, almost 20 plus years company. This old is an old company. It used to be an oil gas company. We have remanufactured it. We are using our old LinkedIn. We have rechanged it. So go there, So now what do we want to do? We want to give all of you, basically, we want to give all of you emails, right? Emails, right? And the purpose of this email is that you have your email, for example, Adelobo, right? Dot your first name, last. What's your full name, Adelobo?
Adedeji. Adelowo.Adedeji.
Adedeji. Dot Adedeji. Okay.
Yes.
Now at nextventure.com. I'm going to show you how you guys are gonna. We're gonna want to get you to. We'll learn all this. Don't worry about all this IT stuff you're gonna learn. Please learn it. Don't just rely on what I'm telling you. This is business side of the deal. But you need to focus on the technical. How you're gonna take people out is your technical skills. Okay, if you're a soccer player, and look at the Egypt team. They went so far as to take on Argentina in the World Cup, right? But because of all the funny business, they lost, right? And so just because Lionel Messi is so top notch doesn't mean the Yamal Yasmin, he came along and I mean he took him out. So the world is always changing and evolving. You need to always think you are number one. How do you become number one, right? So to become number one, you need to be technically what they call technically. You want to think like a SME. Anybody know the meaning of SME? Anybody know the meaning of SME?
Small medium enterprises.
Subject matter expert. Subject
Matter.
matter
Expert.
expert. Yes. So there are a lot of people who come to our classes and they say, "Oh, Nadeem Bhai will help us get a job, and so let's not learn anything. It's no big deal. We don't want to learn this. In the end, we just need to get a job." But the world has completely changed. Those days are gone where you can place somebody at a job and and you think you got a job. There are people who are in this class. I don't want to give a name. They even said it in one of the classes. They went to a company. They spent over $9,000, $5,000 to $9,000, uh, and I think they got a job and they lost the job. So there are people who are teaching all of the stuff not all, some of the stuff we are teaching, and making you believe that you have got to the best people. They charge you $5,000, $3,000. I'm not talking about rupees, dollars, right? So it's impossible for somebody sitting in Nigeria and Pakistan to even dream that they can pay that kind of money to achieve. And they're thinking, oh my God, if I had gone to this code camp and paid them 3,000, I would be at the top. So creating a level of hopelessness in people, uh, trying to be a bully in the market, and trying to cheat and lie to people, which is very common now because since the you know uh, I don't want to get into the details. So we want you to be a subject matter expert. Okay, that's not easy, right? But I'm going to show you how it will become easy. So we have networking that is definitely something that should interest you. We're going to make you very practically good in this. Okay, in Linux. So in Linux, right? In order to master Linux, you got to be playing with Bash scripting. Bash scripting will give you a good handle. Then we have Python, right? Then we're going to talk about, we have 21 projects, which are the RHCSA exam, which is all Linux, 100% Linux. Okay. And then we have a practical project, which has your Grafana. It's on there. It's on the 100 days of Linux. It has Grafana. You're going to see how a dashboard is working and how is a machine is passing data onto a display, right? And then how do you troubleshoot? So we're going to keep on shaking, evaluate shaking. We're going to put you into some practical problems. We have 8 weeks to do that. We'll get to the end of September, and hopefully we can do an evaluation starting every week in September. We'll tell you what the evaluation is going to be. I'll pass you the evaluation questions. You go and read them, understand them, uh, and while you're playing with this, I'll show you how you're going to play. So starting Monday, which is tomorrow, Monday, Tuesday, Wednesday, Thursday, and Friday, um, uh, ev- uh, maybe 11, depending on my work, or 12. I'm going to conduct a 1 hour class in English. We are currently conducting 1 hour classes in Urdu at 6 a.m. I'll be conducting these classes starting now till the end of September every day. Okay, every day. So we already have the Urdu classes. We're going to teach. We're going to spend only 1 hour, 1 hour, practical 1 hour only, practical 1 hour. Right. My goal is to take the next 2 weeks and finish bash scripting. So that's 1 hour all the way up to here. We can finish our bash scripting. Okay. And then we'll have 2 more weeks. We'll pick other topics that we need to gain the skills on. We're also going to get into Python, uh, and we are also going to get into because we need Python because we need to be able to build agentic agentic AI. Okay, right? We will also talk to you after we do Python. What is machine learning? And we'll give you a very practical class, simple, easy class on. Oh, Bilal is here. Bilal, is that Bilal Khan or Bilal Mufti? Right. So that's machine learning and AI. Okay. So we're gonna wrap these classes up in there. We might actually hit the 1 week of October. We have decided not to teach any classes this year until November or December. But then because December, the problem is we hit the month of Ramadan, and then people take a break and they don't come back. So we'll try and wrap this up maybe within a week of October and give a break for 3 weeks, and come to November, we'll start with cohort number 4. Okay. But I'm not too interested in teaching the class, like I told you. Okay. Classes is not what I'm interested in. It's building capacity. If this group, I only get 10 people out of you, 15 people, 20 people, and out of 100 people, I've got a team. Okay. I'm happy because capacity building is what is important, right? So once we give you an email like this one, right, the next thing you're going to do is you're going to go to LinkedIn, on LinkedIn website, and we will show you how to verify. We'll do this on one day when everybody's got the emails. Next weekend, we'll help you verify your emails, and we are gonna we are gonna take whatever experience you have over here. We'll keep it, and we'll give you 5 years of experience in IT under our company. Now, there are a lot of people who tell us that that's you're lying, you're cheating, and it's not part of good faith to lie and cheat. So let me answer that question for you. Okay. So understand that Nexus Ventures is a US based company. Okay. It's a US based company. And and I pretty much own and run this company with our partners. We have other partner companies. We have an app company also. We have a non-emergency medical transport company also. We also have other companies that are tied to this. We have 7 small incubators and companies, including NIT Academy that you're sitting in right now. NIT Academy, you're sitting in it right now, right? They're all connected to these ventures. That's because this is all about ecosystem, okay? Because we want to have an ecosystem, and you should be interested in being part of this ecosystem. Unless you want to go build your own ecosystem, we are very happy. And at some point in time, people will start to do that too, because you have the concept of the city, you have a concept of a village, right? So people will break away, create a village. That's great, because as long as a village is created, that means people are succeeding, people are getting jobs, and people are so scared about AI right now. Everybody's saying all the jobs are going away. AI is taking over, and the answer to that question is, um, who's letting AI take over, right? That's the question. The question is not about AI is taking over. Okay, so who? I want to ask you, everybody here, this question: who do
Yeah,
you think is
still,
letting AI?
still people, obviously. No, people
People?
designed, yeah. So it's all about people again.
It's all
If
People
about
against
people are
people,
people.
developing themselves, AI won't take over their jobs.
right? So who is doing that? There's on Netflix. Um, okay, there is a movie that was put together by the name of Hail Mary. Hail Mary. It's not on Netflix, sorry. It is on some other channel. Somebody had talked to me about. I gave a Juma khutbah about 2 weeks ago, talking about something very similar to that. So, what is the whole idea of AI? You know, it is about the existential threat to mankind, right? So you have some people that have established a belief system in themselves, and a belief system in themselves, right? Nobody has asked them to believe like this, but they have decided this is how I'm going to believe. How am I going to believe? I'm going to believe that I can live forever. okay, which we know we can, right? But not in the way that I want to live forever. So for most people to live forever, everybody has, in every faith, has a clear picture. Okay, if I want to live forever and I want to have everlasting life, what do I do? Like, I don't want to, I want to be alive. I want to be Nadeem and forever be Nadeem. Okay, I want to be Azim and I want to be Azim, right? I want to be Akin and I want to be Akin forever. So you have some people that, first of all, uh, created this belief system that we have to live forever. But we are not going to accept any other way of life except the way of life that we think as human beings is going to make us exist forever. So maybe there is a way that we can transfer what is within our brain and within all the knowledge that we have out there, we can put that into something that is artificially created by us, and we can die and go away, uh, or put us in a freezer, or our bodies can go away, but we can still come back to live, uh, and be here forever. So this is what AI is all about. It's an existential, it's a belief system, it's a hedonistic approach to life, and hedonistic means that it is completely has no concept of soul. It does not have any concept of life hereafter. It's just life is here. The life hereafter is, let's find a way to transfer what's in my brain, what's within my neural networks, what is I've got here, what are the signals I've got, and take all of this. And they're saying, well, in order to achieve this, we just need to keep on creating this model of AI. By the way, let me tell you what AI is in very easy terms. It's nothing more than mathematics and statistics, right? That's all it is. It is the ability of a computer to compute data statistically. It's a thing about probability, and we're going to talk about it. That's why I have this. Uh, you guys are the lucky ones. You will have some extra classes. You will do some machine learning and AI. I want you to walk away with a small certificate on and stuff on your resume saying you have done Python, you have done agentic AI, and you have done machine learning and AI. So what is machine learning? What is AI? We're going to run some models, very easy ones, and you will see what is machine learning and AI. And a lot of people are going to look for you just having this on your resume with Linux, because without Linux, so I will tell you a story. Before I got on the Linux journey, I actually got a postgraduate in machine learning and AI. Okay, and I'm going to give you all of that. I'm going to give you all of that knowledge, and maybe I would say 1 year of work and no job. What a beautiful money I threw away, but I learned something from it. Okay. Um, the journey is that you have currently got an app. Okay, you have a phone and you have an app, and you have a somebody who develops what is known as, in the medical industry, it's very big. You have melanoma, right? Melanoma is a disease, and whether it is, you can see it's benign or whatever it is. So if you snap a picture, you take a picture of, let's say, somebody, this is the hand of a person, a body, and there is this melanoma on it, and you took this phone, right, and you are able to capture that picture of this, right, and then you're able to use Linux to transfer it over to a big data server, big data, right, uh, which is Hadoop, okay, and you get into big data. So big data is what? It's just you've got maybe 4 million pictures, right? And you
Yes.
got a picture A that you have taken, and in this data you got millions of pictures, and it matches this picture with this picture, and this picture is labeled as okay, for example. Yeah, that's okay, or benign, nothing's wrong. So this phone takes a picture of this, it checks with the database, comes back to you and tells you this is this is where AI has become important, right? That's become AI. But in order to build AI, right, you have to have machine learning. You have to have data. You have to start with some data. You have to go out and if you have a farm, start taking pictures of your trees, your leaves, and you start storing all of them and label your plant. Okay, this is eucalyptus, this is okra, this is onion. Okay, so next time when you have a drone that takes a picture of a field, it can recognize if this is an onion field or this is a corn field or this is why? Because it's taking that picture, it's processing that picture and comparing it to big data, and it's coming back and telling you what exactly it thinks it is. So, but the model that works for it to give you that confidence that this is the answer is statistics. So you have to have statistics in the middle of that. Okay. So we kind of went away from today's topic, but that's at the end of our journey. We are going to be here at AI. Okay. So, so AI is just a new belief system, a new hedonistic existential threat to mankind. Somebody came up with this belief and have created such a hype because a lot of the people who are believing in this system are people who hold a lot of the money of 5% of the world's wealth. And they are the ones who can actually put this information out. But for you and I, we need to understand, first of all, that there is no existential threat to any human being from AI at the moment. This is a human created problem, which is designed by human beings. And anytime a human being designs such kind of beliefs, fake believe in people, you have to know that there is a way out of this problem because there is enough stories for people to know what is real and what is artificial. So AI is based on a belief system that this is causing existential threat. There'll be no jobs. I mean, when there was no AI, we were still hearing about no jobs. Now AI has come, there'll be no more jobs. And yes, we are all in the IT world. We are kind of getting pushed every day, like in a funnel, like a funnel. Everybody's getting pushed, pushed, pushed. All the jobs are going away. Okay, no manufacturing jobs, no electronic jobs. Everybody's getting kind of getting pushed into IT. Okay. So, uh, and then in IT, you've got different companies here, right? You've got big names, big name A and big name B. And then they are the ones saying, oh, okay, should I accept this? Should I reject this? Should I keep this? AWS laid off how many people? I've seen them lay off almost 20,000 just about 6 months ago, right? Uh, and these are billion-dollar companies, billion-dollar companies. They don't have any reason to fire people, but they will do that, right? So we have to understand it very clearly that the reason why we are sitting here is to build capacity. What is capacity? The capacity, this is not capacity, this is a funnel. This is a funnel. If you are going to push everybody into the funnel, some people will make it and some won't. That's the fact. And this is the model that they're using. Okay. And if we can get a separate, uh, there's a thing we're going to learn in SRC. We're going to learn something known as the Pareto. Go and Google this. Pareto's law. Pareto, where 20% of the problems in your IT, when we do ticketing, right? We're going to learn about ticketing. We're going to learn about L1, L2, L3 support, right? And so, what is the magic uh, model, right? It's called the Pareto model. The Pareto model is what you say that 20% of your problems, your IT problems, uh, are are creating 80% of what you're seeing. So when you see a problem in a system, it's massive. Okay, you need to focus on the 20%. If you fix those 20%, those 80% will go away. They are focusing on the 20% of human population only. so that the 80% of the human population on the planet can basically just go and live wherever they want. So if if down the line, people are ruined by poverty, people are ruined by whatever needs to be done, heck, we don't care about that, right? And if you look at the geopolitics of every country today, from Nigeria to Pakistan, the east to the west, countries that have minerals and resources, yet our populations are at 80% impoverished, suffering and struggling, right? And while we sit here in the US, we act like, oh man, we are on the top of the world. But nobody in the United States today is on top of the world because the same AI freaks, all these freaks, all these weirdos, all these billionaires who are part of the 20%, they are 5%, right? They are 5% controlling the world's wealth. Those 5% just want to focus on 20% because they think that if we have 20%, then 80% of the world can just go to hell because 80% of the world's problem is on 20%. This is go Google this. You don't believe me? Why you guys are sitting on the internet? Go and Google Pareto. Ask Google, what's Pareto diagram? What is a Pareto diagram? What is a Pareto law? Right? They teach this in schools. I learned it in schools. Pareto. And I'm going to teach you in this class too, right? It'll make you a smart guy. Now, any questions here at this time? I know we are supposed to talk about networking, but I know people are coming back. People want to hear something more exciting to tell you where we are, what we are thinking, what we are doing. So all these Hollywood movies, Pakistani movies, Indian movies coming out today, they are all designed to create disaster in people's minds, a young generation, to create depression, to create a high level of a feeling of hopelessness. But a human being cannot make you hopeless. You because he's as he doesn't have 5 years. He has only 2 years, like you and I and all of us. So we will fight back. That's who we are, right? We are here to fight back, and to fight back, we need a team, and we need a team that has that capacity to fight, not a team that we have seen for the last 2 years, and where people come in our incubator, people join these classes, and sometimes it just surprises us that people would make comments like, "I thought you were going to get me a job." Okay, well, you kind of never completed the journey with us to know what we are doing, right? So, but we're not upset with that because we know people have real frustrations. So we know that they're getting affected by this noise called AI, right? So so Pareto they're following a law called the Pareto's law. There's another law called the zero sum law. This is what the people are operating on. Okay, remember that anytime anybody who has a lot of wealth and institutes in the planet, they're not doing things randomly. They are taking into account some kind of a model, some kind of a model to justify why that model is, and then to validate the model, right? Which is what machine learning is all about. You take a model and you use some statistics, right? A statistical tool like regression, okay? And you will see this when you're doing Anzar, uh, you have done some regression testing stuff, right? Anzar is going to teach a class maybe in a few weeks also. He's one of our ex-students, right? He was in our last class. I pulled him back into this class. So you take a model, what the heck is a model? I mean, what is a model? What is a model? You draw a picture on the board? No. This is based on the rules of statistics in mathematics. And based on this model, you're going to predict that, okay, uh, if I have a probability that I have got uh, red and blue balls, if you know this from your childhood, red balls and blue balls, what is the probability that if I put my hand, I will get a red ball or a blue ball? So imagine as old as this probability statistics was, today this is part of the statistics to predict, predict. Okay. So with the power of computers now, your predictions are getting your ability to predict based on probability have become better and better and better, right? But never, never, never 100%. Never. It will never be 100%. Never be 100%. Why? Because the same AI that is predicting the end of the world is also looking into all the data that exists in every given faith in the planet, right? It's looking at books, it's looking at data, and that data is suggesting everything that they want to predict, right? Until you manipulate your AI to keep giving you staying staying on the left side of the lane and not right side of the lane, which is what we call bias. Okay. So anyway, I've said a lot of things. Let me remove this one. Okay. Any questions, anybody here, before I finish what I was going to say, and then we'll jump into IT, into networking. Okay. So our roadmap is clear, everybody. सबको साफ है भाई हमारा क्लियर रोड मैप क्या है अगले आने वाले 4 हफ्तों का. Everybody understands?
Yes,
Yes.
Michelle.
Yeah, so, and everybody doesn't need to fear because you're not on the Pareto list. You're not a diagram. You're a human being. You're not 20% that is going to, you're not the 80% that the 20% is trying to bring you down. Right now, we are all 80% that are being affected by the 20%, right? So, there is, so you can turn the Pareto model through capacity development into a model that works very well. Okay, so uh, I'm not just throwing things out to you. I'm telling you things that are very scientific, uh, you know, and uh, and are based on the way things are going on today, right? So when we talk about ticketing, we're going to try to solve 20% of the problems that should help us solve 80% of our ticketing issues that appear in IT. Okay, agentic AI, we said we're going to do that as well. Yes, so that's all part of our learning journey. So we were talking about this part. Let me come back to this important part for all of you. Okay, what is this part? Is this one here. Okay, let me remove this calendar. We have already done. We are going to have 1 hour classes every day starting tomorrow, inshallah. And with that in mind, we are just going to do. So let's go here. So we have a website, right? We have this already in place, right? Part of our capacity journey that we have built. Now we're going to offer you guys emails. So you'll get your email. You'll go and verify your email. You're going to add yourself 5 years of experience. So people say you are a liar, right? How can we build something good by cheating, right? This is a lot of people join us and say the same thing to us. How ये कैसे हो सकता है? झूठ बोल के कैसे काम चल सकता है? We know by the principles in which we live, we cannot lie and we cannot cheat, right? So how come you will get your 5 years of experience? How come? Right? And I will answer that question for you. If I give you on your resume 5 years, and this is on recording, right? You're recording this, right? And then I hope you don't go out and share this recording because you'll just shoot yourself in the foot. You won't shoot me in the foot. Okay. So people always have their conscience, यार आप झूठ बोल रहे हैं, बेईमानी करके कैसे हम 5 साल दिखाएं? मेरा दिल, my heart doesn't. I had a guy call me and said, brother, Alhamdulillah, this, Alhamdulillah. I said, look, bro, just be quiet. Do what you need to do. Leave this class and do what you need to do. Because I'm going to explain it to you. Your heart doesn't accept it, then follow your heart. Okay. I'm going to tell you the truth, the exact truth. This company that we have, right? This company is under a professional engineering license here in the state of Texas. I hold a PE. It's called a PE, professional engineering license. I am a PE by exam certified in the state of Texas and a PE by law in the state of Texas can call anybody an engineer. This is in the law book. Can give anybody any years of experience. Why? Because he's taking that responsibility. So I'm taking responsibility that what I'm giving you gives you as much as 5 years of capacity. If you had 1 year of capacity, maybe the class yesterday we did on networking, that would be considered a 1 year capacity. Somebody learns basics of networking, then they get a job, and then slowly, after 3 years, they build that knowledge. So, in the state of Texas, it is, and I will show you this website when we get to the end when you will sign a document with me. So, I'm a professional licensed engineer, I'm a PE, okay, in the state of Texas. There was a company I used to work for many years ago. They used to use my license because they had no engineers in their company. They had nobody who was a single person who had graduated or was an engineer. And they wanted to certify and put. So the state of Texas does not allow you to put the word engineer on your card. It is illegal unless either you are licensed or a licensed engineering company allows you to carry the license. So if you're on our company here, which you are, you can call yourself a Red Hat certified engineer, right? Nobody offers this anywhere, but this is under the laws of Texas, 100% under our jurisdiction, under our umbrella. We know that you have what it takes to be an engineer. We know what it takes for you to be uh, Red Hat certified. We know what it takes for you to get the job done, right? So there is no element of cheating. There's no element of lying. There's no fake. This is all real. So if anybody has any questions, please go ahead and ask me.
No, sir. Sir, this is, I was just want to add something like this is, I think, a normal practice nowadays. Like, a pharmacist doesn't have, investment, but investor, just put some investment, carry the license from the by, pharmacist and start the business. So I
Right.
think, yeah, this is going, this is a model worldwide nowadays, like in the Dubai as well. I have seen a couple of IT companies who are doing that. So I also agree. It's not, at least, at this day, if someone is still thinking this is a cheating, so have some, yeah, they have some point. But to me,
Mhm.
it looks like this is how business is running right now, because
That is it.
the industry is giving the chances to the people who have some sort of certification, even if they are I would say a dummy
Yeah,
certifications.
yeah, yeah. Right, right. And even Microsoft is giving people
Y-
certifications left and right.
Yes,
Right,
yes,
right.
100%.
Right. Because we are working in open source. And open source you have to have s- as long as you have some kind of knowledge transfer, you are good. KT, knowledge transfer. So thank you so much, Azim, for that. So our task is going to take you to verify. So on your LinkedIn profiles, you will all show at least 5 to 7 years of IT experience, right? So if you have 5 to 7 years of IT experience, I would like to all of you who are sitting here today and all those who will get to listen to this video to please build yourself, spend your time. You have 4 more weeks left. Spend your time to become an SME. Pick Take something and become a subject matter expert in within Linux. Okay. And we are going to do an evaluation, and you will say, okay, Linux, by all means, you should be the subject matter experts. Okay, one for sure. You'll That you should all say, even though you may not have the confidence right now to say that. But we'll take you to that part and show you how. Secondly, we have this one where your LinkedIn experience will go up, will show that you have this capacity, you're working for a company, you have that experience, right? And then the third thing is you're going to verify your experience, right? And you can actually say, I work for a company, and I've been doing work for Next Ventures remotely. Okay, all you're going to do is you're going to be working remotely with us, which you are working right now remotely, right? Um, then, of course, we'll come down to the part where we'll have to create your profile, get you kind of to the finish line, and do an evaluation. So that is kind of like our plan coming up. All right. So that was the first 49 minutes I wanted to spend with you to understand. Uh, the other thing is what we are doing on the back. I don't want to talk about that too much. When we get to that part, I'll tell you what are we doing to take you forward to sort of uh, kind of like make money, right? Whether it is rupees, whether it is naira, it is one way or the other. We want to make sure that everybody makes money, right? That's really important to us. As much as it is important to you, it is very important to us, right? Because the more money we can make, the more money we can spend with you, and the more money we make, that means we have growth. So the big thing about making money is growth, right? Growth and innovation is what makes you succeed, right? So we want to have growth, and that's all I will say for this. I'm going to go ahead and if you want to take a picture of this with your mobile phone, then go ahead and mobile phone, you can go ahead and do that. Let me know. I'll go ahead and I'll give you a minute, and then I'll erase this. Right. So I'm going to erase this. No. We had 11:50. We'll take it from this point on. We will follow a strict schedule. We'll take a 10-minute break, everybody, and then we will be back. All right. Thank you. And we'll resume our class where we left it yesterday we're going to do networking part 2. Okay. That's our next 45 minutes to an hour. Very exciting time. You guys will learn something you have never learned before, and how often are the classes held? Classes are going to be held every day, Monday to Sunday for the next 4 weeks. 1 hour classes on the weekdays, and our regular classes Saturday, Sunday, as we have them now. 2 hour, 3 hour, and we'll break out into the Urdu also. So try to do the English in 2 hours and do the Urdu in 1.5 hours. And labs will be Monday to Friday. The Bash scripting Urdu labs are going on. I'm going to start the English labs on Monday, which will be 10 o'clock Pakistan time in the night, 12 o'clock United States time, and 10:30 India time. And Nigeria time, I think it will be 6 a.m. 6 a.m. in the morning. No, it will be 6 p.m. in the evening. So for Nigeria, it is going to be perfect for those who are coming back from the jobs. All right.
Second
Oh,
part.
okay. Thank you. Thank you. Very important. Very important. All right. So, one second. One second. I'm sorry about that. Then we can. Right. So, what we're trying to do here is we've got what we are saying in a decimal. We have a decimal system, and we have a binary system, right? So you start with the binary system 0, 1. When you reach 9, you have to start with 0 again and put one additional number, right? You put 1, and the 1 stays all the way same until you get to a point where the 9 in this case becomes a 0, and the 1 has to now go to the next number, which is 2. In a binary system, 0 will convert to 1 and 1 will convert to 0. But now as you move from this one to the next stage, the 0 has to become a 1, keeping the 1 as it is. And when you move from this one to the next one, right? Because what you got here right now, I'll show you something very interesting, is that this is here, let's put it like that. Right, this one right here, right? We got 0 to 0. I may not even make it. This line is too complicated. I want to keep it as simple as I can. I don't know what's a good way. In fact, what I'll do is I'll remove this. I don't want this to be busy. You can see that clearly what we're doing. So your mind shouldn't be here, okay? So this is mapped at 0. This is mapped in a digital 1. This is mapped in digital decimal 2. This is our 3, right? This is our 4. And this is our 5, okay? We're mapping it to our decimal system, okay? So let's keep on going a little bit. So very easy, very interesting. This binary to decimal conversion, we're not going to be too interested in it, but we'll get an idea how the two systems were developed. So you need to understand how the two systems were developed. And if you understand this, then for the rest of your life, you will not have a problem of understanding how people get so confused how binary decimal systems convert or hex system converts. So let's keep on going, right? So you have, so when we get to 5, this is good. The 1 will stay as is, right? When we go to 6 now, right? We're going to have, yeah. So this one will go to 0, right? 0, and this will go to 1, right?
0.
And no, so this will go to so you have 100, 101, and the 1 will still stay the same, right? Because your conversion from 0 to 1, 1 to 0, 0, 1, 0, 1. Yeah, this will be a 1, and the next one will be a 1, 1, 1. When you get to your number 5. Number 5, this is number 6, and this is number 7. Okay, so little interesting. If you look at how the decimal we increment, so we went after we reached a 1, we had to go to 0, and this one went to 0, but we added a 1. So we are going to leave like this one here. We have left all of this in place. We have left all of this in place. All this 1 is left in place. We have the 1 in place now. This is a 3. So now you have to take the 0 becomes a 1, and the 0 still is a 0, and the 1 stays the 1. You come to the next stage, you take the 1 to 0, and you take the 0 to 1, and keep the 1 as it is 1, right? Because if you look at the changes that have happened from here to here, these are all different. You have 1, 0, 0. So your 1 is still the same because you bring it down. Your 0 is still the same. The 0 became a 1. Now the 1 became a 0, and the 0 became a 1, and so 1, 1, 0. And then now you have 1, 1, 1. Okay, 7. When we go to 8, right? When we go to 8, remember that when the decimal system, right, is a system which we will come to know of to some kind of a power n, right? So if you have 2 power 2 to the 2 to the power 0, it is equal to, so this one here will become, as eventually, we don't need to worry about all of this because mathematics, people teach this all the time in mathematics, this happens, but if you look at this, if you want to see the pattern that they develop, is this is 2 raised to power 0, 2 raised to power 0, sorry, 2 raised to power 0 is 1. Where are we at? Sorry. So, but let me not go there. No. I don't want to get into all of that mathematical garbage. Okay, that's not important to us. We want to stay with learning Linux and what's important to us. So 2 is one of the numbers here, right? 2 is a number that is going to become important to us. Hold on a second. Here we go. Here we go. And let me find that too. This one, of course, is going to become important to us. Okay. The next one that's going to become important to us is 8, right? We talk about 4 GB RAM, we talk about 8-bit, we talk about 16-bit system, 32 IP addresses are 32-bit, right? So we are kind of building a picture of where this is going. So let me just keep it simple and let's go to 8. Okay. So what is 8 going to be, right? What is 8 going to be? So 8 is going to be 0, 0, 0, 1, right? That's what 8 is going to become, right? That's what 8 is going to become. So we kind of now know a pattern that we can see in front of us. That's how this pattern is built. The decimal system, this is how it was built. The binary system, this is how this was structured and built. That's how the binary system was first built, and then you can develop all the math from it, that what people were able to see mathematically, what does it give you. So don't worry about the math. This is how the decimal system was structured, and this is how the system actually came to be. Now, if we are going to look at a number, for example, a simple number like 5,000, right? Let me take one, 506. Let me just take a number, 207. Okay. So this number is really 5,000, right? Okay. And it is really, then you have 5,000, you have 6, you have a system which is 0, 0, 0, 0 here, and then you have a system which is 6, 0, 0, 0, right? And then you have 2, 0, 7, right? And you have 0, 0, right? And then you have a 7, right? So you can see this progression, because this is like 5.
Sir, instead of 207, you have to put 200,
000.
200
Oh, sorry.
here.
Thank you. 506. So all of this really is a 5, a 0, a 6, a 2, a 0, and a 7. And we are multiplying this by whatever that number is going to be. 1, that, and multiplied by 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5 times, so same way. So this is a pattern that was recognized. Now, if I took this on the other side and we had 1, 0, 1, 0, 1, 1, right? I'm just telling you how the decimal system was developed, how people looked at it in the simplistic form, right? The people who developed the decimal system weren't thinking, they did not have a PhD degrees. Okay, they were simple people. An idea came to the mind of the decimal system, and they started to work on it, and they saw a pattern, and they started to playing with the pattern, and the pattern seemed to fit very well, like a jigsaw puzzle. Okay, so I've shared with you the decimal pattern on the left-hand side. Now let me look at this pattern on the right-hand side. So this will also be the same way, right? You'll have 1, 0, 0, 0, 0, 0, right? And the same way, you're going to have a 0, 0, 0, 0, 0. And the same way, you're going to have 1, 0, 0, 0. And you're going to have a 0, 0, 0. And you're going to have a 1, 0. Let me take that out. Okay, you don't have that. And then you'll have finally, you'll have 1, right? And again, you will see that they were able to match that pattern that you have over there, right? Now, what is important from all of this, that came to the understanding is that we have, we have one. What is this? We have where are we at? Where's the pen? Okay. So by developing this binary system, right? So if you notice here, what is one? Okay. Right here, if you notice that we have got one, right? Because this is one. And then if you look at 2, it is 1, 0. So this is 2, right? And if you look at 4, where is 4? Do we have a 4 in here? We didn't have a 4 in here. We have a 1,000 in there. We have an 8, right? We've got an 8 in here, right? And so what was noticed is that that you have this increment in multiples of 2s, right? In the multiples of 2s, you have 2, right? And then they said, okay, you have 2, and if you have 2 raised to power 2, that is 4, and then 2 raised to power 3 is 8,
Eight.
right? And then you have 2 raised to power 4, then it go to 16, 32, and on. Okay. So this is a basic structure that I want to show you. One second. Hold on now. Right. 1 second here. Hold on a minute. Thank you. Okay. Good. This is help. So we have our picture, network picture. Okay. And so this is the network you're sitting in. And we want to look at this as where there's money today in the industry called the campus environment. This is becoming a big business, a campus, right? This is a campus model. I don't want to use a home model, campus model. Okay. That's what it is. This is a campus model. Right. Now look at these two diagrams. Okay. In this one diagram, we have a network whereby we have an IP and we have two things that this machine has to have. What is the first thing this machine has to have? It needs to have an IP address, 192.1, right? Sorry, 168, right? Let's go to the right. Let's go to the right. So this is the data center that all of you are coming to. Okay. So rather than using a fake, I'm going to give you a real scenario. So you are this is the data center right here in Houston, Texas, where you guys are coming in. And this is your Zen Orchestra application that you're using. Zen Orchestra, you guys have your machines. You sit on this host. This is the host, right? So we're going to do this in a practical manner, right? That's our goal. We want to do all of this in a practical manner. And let's go here. And we have this coming down. And of course, we can have this coming up. It wouldn't be that way. We'll have to take that away. And I'm going to just do a campus model for now. And then we'll do a dual router model for you guys. So let's do that to make life simple, because there are 3 models actually to learn this and master this. So I'm taking the middle model because middle can go left, back, low model and a high model. So we can, if you know the low model, we can build the higher complicated model. So this is the middle level. You know this, you pretty much know the high and the low. Okay, so you're an SME. So as an SME at a job, okay, you are going to look at data, and data is a bunch of binaries, bin, right? Binary, and has to be a packet, right? and we are going to analyze. We have to analyze these packets, right? Analyze these packets. And then these packets are going to go, and they're going to go uh, from source to destination, right? That's what these packets are eventually going to do. That is the goal of us having this network. We are all connected because I'm talking, you can hear me, right? So destination. So our goal is to get them to that destination. So that's what an SME in networking has to understand the mechanic. If you are like a mechanic of networking, what is it you subject matter expert must know? A subject matter expert must know that we are moving data, right? We are moving data internally. If we are moving data internally, then we are sitting in a local area network, right? If we are moving data outside to the internet and out along the world to another local area network, this local area network is there too, right? This is another local area network. We talked about it yesterday. And all of this is part of the WAN. All of this is within a WAN, right? We drew that diagram yesterday and we said we have one box here and one box here. So today I'm showing you the two boxes, and this is the WAN, right? Wide area network. Cables in the world connected, taking us and connecting, providing us the required connectivity from this point to this point or this point to that point, right? So we have a LAN and we have another LAN, two separate LANs. Okay. Now we have, all of you have some machines in here, right? We have a bunch of machines. Everybody's got a machine in here. And we have my machine I'm using, which is 192.168.1. So this LAN is giving you 192.168.1.x, right? X. We need to determine how many can this LAN give. We'll talk about the classes. We're going to talk about all that next week, but I just want you to practically understand what we're doing here today, right? So it is going to assign, if it assigns this side of the router as a 256, okay, dot 256. That is, sorry, 254. I think it's 256. Yeah, 25. No, we can't go 256. 254. Sorry, because maximum is 255. Sorry, 254.
Yes, 255.
254. Right. And this side of the router is called a gateway, right? So the router, a physical device has got an IP, and that IP is the IP of gateway, right? And if you guys are able to ping, we'll do some practical uh, of this through the week. We'll take 30 minutes of bash, 30 minutes of networking, and these recordings will be kept to about 1 hour, so that you guys who can attend the class can just look at the videos and work through the small practice labs that I'm going to put starting tomorrow, right? So this LAN is a LAN that has given out some IPs, right? There's an IP here for, let's say, 99, right? And inside this where you have the actual server, the server has an IP. You guys don't know about that IP, but within the server now you have bunch of virtual machines, right? Inside the server you have virtual machines, and all of you have IPs. Like somebody has a dot 2 in the end. Maybe you have a dot 97. So you have some IPs that are assigned to you, right? And that IP, and we'll come to that part. Okay. So let's go look at the LAN on the left hand side. Let's look at the LAN on the left hand side. This LAN could possibly have 192.16. Sorry, 168.2. Now this was a
Excuse me,
one.
boss. Excuse me, sir.
Yes.
What about the switch? Are we going to give it MAC address or no?
We are coming to it. We're coming to it.
Oh, okay.
Yes, yeah. So we'll come to that. Very good, very good. I like that. We will have a MAC address. Yes, we'll put a MAC. Now, one of the things that we are going to do here that everybody will understand this very clearly moving forward, right? Is let's go here. Let me pick up the white one. Okay. So you guys are let's see, I want to use data. Okay, so if I use data, let's go this way. I'll use data. Right. So what we have here, ladies and gentlemen, is that we have in the middle, we have a router. Okay. We have a router. Right? And this router, ladies and gentlemen, has something on it that we were going to talk about. 1 second. Let's get the yellow. And here is your machine. Okay. And this machine has 192.168.2 because we are sitting on a 1. And let's say that your machine has maybe 44. So this is the IP address of this machine. But at the same time, this machine has a manufacturer's thing called the MAC ID of this machine as well. And if I can pull, let me see. Okay, maybe I'll take a look at that, which is okay. I want to put the second here. There we go. Right. So, in order for us to communicate, right? One of the things that happened to all of us, we have. Let me see. Let's fill in the blanks. Like you see, you talk about MAC address and all of that. Let's get that 3 things out of the way. So let me take. Okay, maybe I'll just take white. Okay. So we have layer 1, right? We have layer 1, which is our physical layer, right? This is our physical layer, right? And the physical layer is connecting you to the host or the client server, right? So here you are now connected to a server. Okay, and the orange ones that you have, these orange ones is going to be, and the only way you can understand is be patient, ladies and gentlemen. Just be patient with me. MAC. Okay, the MAC address. Okay, and we are not come to the switch yet. We have not come to the switch yet. The switch we can put it in here, which is let's put the switch here. All right, we can put the switch over here, and the switch has got, this is the switch, right? There's the switch. Now, what you have got here, ladies and gentlemen, is when all of this are devices, all of these devices that are manufactured, you are given router, okay? Each of these devices are coming with what is known, we talked about yesterday, a network adapter card. Okay, a network adapter card, which is the NIC. And that NIC appears in 3 different ways for Windows machines, for Windows machines, for Linux machines, and for Cisco routers. In Windows, you're going to see, uh, uh, I believe you have a hex method. Cisco uses like a 69.29 dot hex. Let me open this for you real quick. Let me open this file. Let me get this out of the way. I'll get you a little device help. One little bit of patience, guys. Little bit of patience. This is going to be fun. Next 30 minutes are going to be very fun. Hang in there. All right. Okay. So let me open this presentation, which I'm modifying. 1 second. Hang in there, hang in there, hang in there. We're going to put the pieces together so that your mind would be addressed what we are doing here. Okay? Mhm. 1 second, 1 second. Right, I finally loaded it up. Perfect, 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 perfect. Where are we at? Let me see the right. Mm, little quagmire. Let me see if I can fill this up. Right. So MAC address is a 48-bit versus an IP, which is 32-bit, right? It's a media access control, right? 48 bits, and this is going to be part of your presentation. I have this from the last time, okay? And we can actually do a little lab on finding and discovering our MAC. In the good old days, it used to look like this, but that's not the case anymore. That's not how it is. Indeed, they come into your laptops in a much sort of a solid state electronics, no longer the way you see the picture in there. So what really happens to start your journey in understanding MAC addresses? Let me go here for a second. One second, 1 second, 1 second, and then, ladies and gentlemen, I'm there now. Yeah. So the MAC address already exists. Okay. The slide I was showing you, it takes you to a website. You can type the information about your laptop. It's going to tell you exactly your MAC address. It'll tell you this is when they build the laptop, the network adapter card comes with an address. So when you flip this machine open, so let's now begin. So when you turn this on, right? When you bring this machine and turn it on, right? You turn it on, right? So before any network traffic is flowing, so let's begin our journey. Put this straight in your mind. You're sitting in your home. You want to communicate on this class today that you are attending. You sit at home, and before any network traffic flows, the operating system, right? The OS, the operating system of your machine, right, recognizes that there is a 1 second here, so that you don't miss this. Very important. Don't miss this, guys and girls. Do not miss what I'm about to show you. This is everything put together that you have. So you have, it recognizes that there is something called a MAC address. It recognizes this device within your laptop. I'm just showing it for pictorially outside for clarification, right? So this is all out here to show you for clarification, and I'll tell you why, because we are about to answer the question why, right? So you turn your laptop on, no traffic is flowing, operating system comes on, what does it read? The operating system is the one that reads this MAC address in your machine, right? The computer doesn't need to ask or search for its own MAC address. Remember that. Every device that is out there has a MAC address. Every device we have talked about, right? I'm putting in here. Every device has a MAC address. This is the manufacturer's. Manufacturer has already put it in there for you, right? So when you turn the machine on, you flip your thing on, you got to turn on, your operating system comes alive, and while it is going through the booting process, it recognizes that it has a device. So when we learn booting processes, you're going to understand this better, because we have, from 2 weeks from now, we're going to talk about booting process and kernel and all
I'm
that.
sorry, sir, but there is some background noise. Can I understand? Sorry.
Background noise, okay? आ रही है कोई background? अभी आ रही है?
नहीं सर, आई थिंक हमारी साइड पे नहीं है, मे बी
No.
लाइन ब्रेकेज हो,
हो
इंटरनेट।
सकता है। ठीक है, कोई बात नहीं। ठीक है। तो when you open your laptop, the laptop goes through a boot process. When you turn a server on, it goes through a boot process, right? We've talked about this. But let's talk about your Windows machine, because it is talking to a Linux machine, and you're going to SSH into this server. Or simply put, right now, we are doing a Zoom meeting, right? So before any traffic is happening, machine turns on, goes through a booting process. Part of that booting process is to be able to search. The computer doesn't need to ask. आवाज आ रही है?
यस सर, आ रही।
Right. कोई बैकग्राउंड में प्रॉब्लम आ रहा है?
No, sir, we good, sir.
All clear, all clear.
All clear. Okay. All right. Very good. हिम्मत रखें. These 20 minutes of your next life is going to change the way you look at the world of internet. There are a lot of people, a lot of experts teaching this thing. And believe me, I watch them, I listen to them, and I'm thinking, man, this guy missed the point. Man, this guy missed the point. And you can even detect the fact that they don't have a clear understanding how this is actually all coming together. They're just parroting it. "Ke yaar, ye hota hai, this happens, that happens. This." So I want you to be very clear, because we are going to learn about a boot process, right? And we are going to understand that when this thing goes through a process, it goes through a BIOS, and through the BIOS testing, it starts to find out all the devices, drivers, MAC address. This is a device. This is the device. Your operating system recognizes this device. When we read the boot process, I'll tell you the device. So remember what a device is. One of the main devices is your NIC card, your network adapter card. Okay? So keep that in mind. Don't forget that. Now, let's move forward. We have, right. So number one, the MAC address is already there. There is a MAC address already there, existing, right? The manufacturer has given that. Operating system is coming on, doing a post test, and immediately it finds out that device is there, it recognizes. Now comes in what is known as the Wi-Fi or the Ethernet or the layer 2 that he was talking about early on. So the Wi-Fi, the laptop now performs something that we are not going to learn, but it is something called the so you have a Wi-Fi device, and you know that you guys put a WPA key. If you, anybody, all of you, if I come to your house, you're going to give me a password, right? Because
Yes.
that is in order for me to do that, I need to have a WPA or a WPA2 keys. Okay. Now, Is this helpful for Linux? Some people will say no, but you need to understand the whole process. So there is a protocol, an 802.11 protocol that is followed. We don't need to worry about that, right? Because we're not going into the protocols of the certain EE protocols. So once they're connected. So once this connects to the Ethernet or the internet that is available, right? Now you have that in a lot of the companies, what you're going to have is you are going to have, I want to put this in yellow, in a lot of the companies, you will have what is known as a DHCP server as well, right? And our discussion today is not on DHCP server, right? A DHCP server is once this is found, right? And if you're sitting in your in your case in the company, this in your house, for example, right? You don't have, you may have a wire to your machine coming here, just like this wire, right? Or this may be just that box which has which gives you the information. So we don't want to confuse your house network. Now, house network is not a good way to teach networking. So forget about the house and think about this sitting from a campus environment. That's why I said we are talking about the campus environment, right? So a campus environment, any machine that is coming on, either it has a static IP that has been assigned by the admin, or you have a dynamic IP. Every time they turn it on and turn it off, it's going to give you some dynamic IPs. These IPs are within. If this is a lab in a campus, if this is a lab, you're sitting in a lab on a campus or at a work, this is your work site. Okay, if you're sitting at a site, right, you have these IPs coming to you, right? Some of these IPs can stay dynamic, some can stay static, right? So you go through the first process, it recognizes the device, it also then recognizes that there is internet. Now, layer 2 is up, so the computer now needs a layer 3, right? Which is IP, right? It sends out a DHCP discovery. We talked about that yesterday. So this is going to send out, it's going to send over the wire a discovery, and this device will come back, and they'll go back, and they'll come back, and at the end of the day, you will get an IP. You don't need to worry about all of that. You can go read it on your own, but this is where that DORA is happening, okay? That I talked about yesterday. Now, once the DORA is done, right? That is when the address resolution protocol happens, ARP. Okay. ARP is if you are sitting within a campus environment and you or a site, a job site that you're sitting in, and you're not going outside and you're staying within this LAN, you're sitting within this LAN 1, okay? You're not going to LAN 2. You're within LAN 1. This is going to put out an ARP. And ARP means that it's going to go out there and say, hey, is there this is my MAC address and this is your IP, do you recognize me? We're going to leave this ARP alone. ARP is a subject on its own. I just brought it up yesterday, but keep it in your back of your mind. If we don't do it, that's fine. If we do it towards the end of the class, fine. Okay. So when your laptop wants to send a packet to another device, right? Like for example, you want to communicate to this server, right? You want to come out and communicate, and you want to go this way. This is the route you want to take. Okay, you want to come out. So the route is this way. Then that's when the IP of this, which is it has given it an IP. Let's say the IP of the gateway here is 0.1 in your house. Therefore, for this gateway, that ARP, it broadcasts an ARP, and it says who. It's like you sitting here say, hey, who has this 0.1? 192.168.1.1. Who has it? Does this guy have it? Do you have this one have it? Is it the database have it? Any other device have it? no, this one has that particular one because this is what I want to do is I want to send data out. So that's all the value of ARP. That's all you need to worry about and nothing more than that. Let's move on to understanding something really important now. Okay. And that is the OS model we talked about yesterday. We have covered DORA, we have covered POP, we have covered how your machine comes on, recognizes device, and you have a MAC address, right? Now, let's get to the last part of this class and the most important part of this class, right? So, literally, right? Literally, we have 1 second. So we have the routers, we have the switch. Okay. So the one I'm going to do over here for you guys, I want to just show you something real critical. Ji, आवाज आ रही है?
Yes.
You can hear me? Okay, good.
Yes. You can hear.
Right. Right. So let us start our journey from we are going to, let me clean all this up. Let me clean this DHCP server. We also have a DNS server. We haven't talked about that, but we'll talk that all in case and when we do the lab. So let me show you what is going on in here. So we have a machine. We have a machine that is sitting next to this machine. Okay. We have this machine. This machine has an IP. Let's say 192.168 .2 and let's say .44. Right, this is a .44 machine. Here, .44. Okay. And what you have here, ladies and gentlemen, is you have got with you right here is layer 1. No issues. All your binary data 01, 01, 01 is going on this binary data, right? That's your physical cable. Now let us talk about the fact that you have, let's put the model here first. Let's put the model here. Okay, and the model is we have 7, right? And we have 6, we have 5, we have 4, right? And we're going to cut it off over here for a second because we want to discuss these layers only today. We have an application, right? We have presentation, right? We have session, right? And these are all put together. And we come down to transport, okay? Then we come down to number 3, which is our network. And we're going to play the model. We're going to put the pieces in here. That's what you guys are supposed to do for me. And I'm going to ask you and you're going to tell me and you will understand from that point. And data link, right? And then we have the physical layer, right? Physical. Right. So remember, ladies and gentlemen, that the job of the IP addresses, right? The job of IP address that we are talking about, right? We have a transport layer, right? Sorry, we are with data. There we are. So we're going to look at 2. Okay. So you have a MAC address here. I'm just going to call it A1. I'm just going to call it A1, right? And I'm going to call this B2, B2. I'll call this B3, B3, right? And I'm not talking about the switch right now, right? We're not going into the switch. So we have a MAC address for the switch. I'm going to remove the switch for a minute because I don't want to talk about switching. Okay. So we just want to understand a very simple model for now. And then you have You have this device, which is E, A, B, C. We have A, B, let's call it C. We can call it C, C4, C4. Okay. All right. Data link layer, ladies and gentlemen. Data link layer. Okay. What is this? Can everybody tell me what is A1, A1, B2, B2, B3, B3, C4, C4? Anyone?
So this is a format for the MAC address usually.
These are MAC addresses, right? These are MAC addresses, everyone. When you are looking in your mind, when you have this picture in your mind, you should be looking at this orange color. This is the devices. These are physical devices that are coming by the put in there by the manufacturer. When you are paying for a router and paying a lot of money for it, it has routers that can connect to LAN 1, and it can then take it and give it to LAN 2 on a campus environment, right? You can go router to router as well. You can put in here a router right here, okay? And if you put in a router, then of course you're going to have a D5, D5 and E5, E5 this side, right? One side faces one LAN. That's why I put these boxes. So one side is facing one LAN and one side is facing one LAN, right? Here you go. Here's your orange layer. Here is your layer 2 working. What is the job of the MAC address? Okay. MAC addresses, again, we're talking about addresses, right? MAC addresses are allowing us to do a hop. We are going to learn this word hop. Okay. When you hop from here to here, and when you hop from here to here, and when you hop from here to here, layer 2 is responsible. Layer 2, where you have the MAC addressing, which is an address of a physical device provided by the manufacturer. What you're doing is a H to H. What is H to H? Anybody? Hop to hop. Hop to hop. That's what it is doing. These devices help hop to hop. Now you're asking this question, what the heck is that? Okay. We haven't talked about IP addresses yet. You will see where we are coming with this. So understand that MAC addressing provides you hop to hop. So what do I mean by that? Anybody wants to try that? Anybody has done some networking? Anybody that can tell us clearly what a hop to hop is with the MAC addressing? We are learning networking, ladies and gentlemen, and we are building a network, and we are building capacity in bit of networking. We're not just gazing to networking for Linux. The commands that we're going to run in Linux, a lot of times those commands are very simple commands. And when you do a TCP dump command and you're looking at hop, it is hopping to and hopping between IPs, right? That hop, there's a hop, right? We're going to learn about a command, a TCP dump command, right? And when we run that TCP dump command, it's going to give you a bunch of hops, okay? So when you look at hops, and you read, and when we read a packet tracer, when we're tracing something, we're tracing data as data is moving from this part. So we have got data over here, ladies and gentlemen. I didn't hear anybody give me any explanation. So I'm assuming either you don't know, or you're too shy to tell me, or you have never heard of this before. What is the
I think
answer?
it's transfer of data.
Okay.
I mean, probably between maybe two devices or something like that. I think that is software.
Okay, I
Maybe
appreciate
from
that.
switches switches to router or something like that.
Take the switch out for now. Don't worry about it. Just look at this diagram. Just look at this diagram. So
Okay.
you see, one of the things that we are going to talk about, right? When we talk about something that is very important to us, we have to finish this class on all the 3, 4 layers. Okay. So
Okay.
I don't want to close this class until we are clear here. We said 30 minutes, but now we are talking about hop. Hop. The word is I've used is hop. And probably when we run a TCP dump, when we do Wireshark, you're going to see the word hop. So
Okay.
you're hopping and hopping and hopping. What is hopping then? Right? So let me explain to you, because you need to understand this. This is a real problem that came on a job for me. That's why I decided to completely change what I taught before and completely go on a different route, because this is something that you need to understand, and forever you will never forget it. Okay. Now, what is a hop? What a hop is, ladies and gentlemen, the data is starting from here, right? We have a bunch of information that is put together in here. In these three, 7, 6, 5, you got data. Okay? You got data. What is data? It is some bunch of binaries,
Binary.
right? Thank you. Data. Your application decided to put the information. It went to a presentation, which is giving it encryption, and then it does a session. So it's all got bunch of data. That is why we draw the line here, because our data is actually largely 765. 4321 are important to Linux admins, right? And 765 is now becoming important, because the only way you can do this, look at application stuff, is we are going to look at it is through your dev tools next week. We're going to do practical dev tools, right? So let's not go there. Clear your mind. We got data. Data is coming down, right? So we have this data. Let's just say this. So remember, the layer 2 is layer 2. Layer 2, ladies and gentlemen, don't go to sleep. Don't walk away from this class. Your next 30 minutes is all you need. You will never need to watch this video again. Okay? Because if you can take 30 minutes now, you got it. You don't need to waste your time watching the video. Stay here, please. I'm requesting you. You don't need to watch my entire 2, 3 hours. Okay? And forward it. So you have a layer 2, right? A layer 2. All right? This layer 2 is directly connected to layer 1, right? Because this is kind of like where the NIC card is, right? This is where the cable is plugged into layer 2. The physical cable is plugged into the data link. That's why it's called the data link layer. You're linking your data here to the wire. So that's why it's called a data link layer. Let's look at the data itself. You got data. We're going to look at this one, right? You got data in here. All right, this is data. Where is the data? It's all coming here. I've already drawn it up here for you. This data is coming. This is the same data. We don't care what's inside the data. It's a binary. For all we care, it's a binary, right? But then we have something that is put on top of this data. It got a header, okay? And that header is telling you it has basically got 2 headers. It has, what am I going to use for layer 3? I'm going to use, I'll use green. I will use green or purple. Purple. Yeah. Purple. Okay. I have one layer over here. I have source, I have destination. I have source and I have destination, IPs. So I have in here the IP address of my source. Let's say it is whatever 192.168.2.44. This is my source, right? I have my destination. I have an IP address for my destination. 168.1, let's say .99. So I have two IPs here. This one, source to destination, right? This is a header that has been added in here to this data. In addition to that, when this packet is moving, you have another thing in there. And what is that? You have A1, A1, A1 for the source. And where is the destination, ladies and gentlemen? Anybody can fill this one for me?
C4.
B.
C4.
Very good. B2. Yeah, sorry, it's B2, B2. Very good. B2, because that's your first hop. Hop 1, right? So the data link layer is telling you is a hop to hop because it is going from a MAC address to MAC address. That's how the data is linking like a chain, making sure that when you're climbing a mountain, that you put the hook, that you make it to the next. When you're driving a car, you see a milestone. That milestone is telling you what? That the IP address, you're in Rawalpindi and you're going to Karachi, straight road. You're in Dallas, you're coming to Houston, straight road. You're living in Lagos and you're going to Sokoto or Kaduna, straight road. You're in Canada, you're going from Toronto to Quebec, right? Straight road. I mean, of course, the road is not straight. Logically speaking, a straight connection. Point A, point B, right? IP addressing, ladies and gentlemen, IP addressing is end to end. Okay? It is an addressing that handles the end to end. To end is this is end number 1 and this is end number 2. You see an IP here, you see an IP here. Do you see
So
anything
Nadeem
else?
Bhai, this when the data packet started, it has a both IP address start and end one
It
in
has
the
the
header.
source. In the header, you have the source and the destination. And we
Okay.
will finally do the data. I'll take the data one by one. Well, right now, I want to explain layer 2 and layer 3, what happens in the hop. Okay. Then then you can understand what happens to the data. Right? The data gets a bunch of headers. Yeah, so yes, you're right. Very good. But let's stay with this layer 2, layer 3, layer 4. Then we will look at taking the data, finding the transport header, finding the network IP address headers, finding this. See, most of the classes go teaching it that way, right? So we don't want to go teaching it that way because it's too busy mentally. You need to understand that when you have data, right, end to end, it needs to have a source and a destination IP. Yes, end to end, आपको IP चाहिए, end to end. जब भी layer 3 लाती है end to end. Layer 3 is called end to end because you just need a source IP, then you have the destination IP. This is the destination and this is the source. When you get a message back, an acknowledgement, right? When we are going to talk about TCP and all that later on, then now this becomes the source. This becomes the source. and this becomes the destination. Okay? That is end to end. That's what layer 3's job is. It is an end to end. Okay? But the hop is not end to end. The hop that you have got is first is MAC address to MAC address. So when the data reaches this machine, B to B, B to B2, right? Now, ladies and gentlemen, somebody tell me. I'm going to give you a quiz. I want you to tell me. I am now going to do a hop number 2. And my data is still intact. I still have my data. I still have my IP end to end. So where the destination is, the car is going, source, destination, end to end. Nothing is changing in this. We're going to talk about the packet. We're going to talk about the header. We're going to talk, we're going to talk about segment, packet, and then the frame. Okay. So the data is intact. The colors that are changing is now we have what is going to come here, ladies and gentlemen, and what is going to come here. Tell me.
B3, B3, and
Yeah, B3,
B3,
B3
B3. Thank you.
to
B3,
DSDF.
C4,
B3 and
Oh,
D,
yeah,
yeah,
sorry, D-
and
D.
this is DSDF. Thank you.
DSDF, yeah.
And now you know that when we get to this, and then because once it arrives at the router, ladies and gentlemen, that data, the next thing that the router, that's why we say it's logical. It's a logical OSI model. It's not exactly everything, but it is logically, that's the way it is. Why? Now it has, when it reaches hop, this hop now says, hey, this is the way it's coming out. This is the way it is going. So when you are troubleshooting hop to hop, when you are troubleshooting hop to hop, and we are going to run, we won't run it today. We'll run all the practical labs next week or through the weekday. Hop to hop number 2, hop number 3, right? You know what the hop number 3 is going to be like. Hop number 3 is going to take, what is in hop number 3? Let me remove this. So we have, but tell me, ladies and gentlemen, did the IP source destination information get changed? No, because it is end to end. Until it reaches the end and gets to that IP, there is this data that we are talking about, right? It's the only thing that's changing and getting stripped. This is what is getting stripped, right? When it reaches this point, it strips this one away, it takes it away, it adds this one. This is the one we have added here. And it adds the next device that it is going to go and find that routed. It's going to find the next MAC add MAC. So the MAC is the chain. You need for a fact the machine out there. And how do you know the machine is out there? Right? The way you know the machine is out there, it is a human being that has manufactured a physical device called the NIC card that is inside that device. You can't go wrong with that. So if I find my device and I know that device on the router, on my route, can tell me like a rest area, it is there. The rest area hasn't moved. Okay. So now it will strip it. And so this is what is happening, hop to hop. Okay. That is what it does, hop to hop. Are you clear? Is everybody clear about this?
Yes.
yes, clear.
Yep.
MAC address, what does it do? It manages the hop to hops. It's a hop to hop layer. If anybody asks you now, why MAC? What is MAC going to do for me? What is MAC address going to do for me? It's an address. You need the address because this is by the manufacturer. It is not something hanging in the planet, a cloud moving above your house, wind blowing around your home. You can tangibly capture it. It's not a Wi-Fi your eyes cannot see. This is something your eyes can see. Does exist. Different. The MAC address. That's how layer 2 comes into play. Layer 2 gives you the hop-to-hop sort of connectivity across your network. It gives you the capability to say, okay, I've got. So when you are troubleshooting as a network engineer, basically network engineers, as far as we are concerned, all network engineers, all of you, if somebody tells you tomorrow what is a hop to hop, you'll say, well, it's MAC to MAC. You take the data, you take the MAC address of machine A, and takes you safely to machine B. From machine B to machine C to D, and the hops could be 48 hops across the world, from Nigeria to Houston, from Houston to Dallas, from Dallas to Karachi, Karachi to Pindi. You could have 48 hops, but it's going to find that whole network of routers that are in the planet available to carry that for you, right? If you're taking that through the Google server, Google has a network on the planet, right? The internet, interconnected network. That's what the routers will give you, right? So
And the
I hope
MAC
that
address is always static.
it is always static. It's burnt into the machine.
Okay.
The
The physical
manufacturer,
device, right?
right? No, it's a physical device. It's a physical device with a number that is hard coded in today's modern day machines and routers and switches, right?
So Nazim
Uh,
bhai, when we ping the some server, is the same process. He go back, reach our destination, get back us and tell us that many packets we send and that many receive and that many lost or don't lost or something like that. When we ping the server or some other machines,
right.
it's kind of
So
same process.
so so uh, so two different things, right? Good, good. You're thinking in terms of layers now. You know, the hop that you are getting, you're not gonna get the hop from you're not gonna get the hop from your ICMP ping command, because ICMP and ping, we're talking about that end to end, right? You're pinging something end to end. In between, for it to ping, you do have the what do you call this thing? Uh, MAC addresses where the data is going through. It's okay. So now you're talking about pinging. Okay. So let's hang on to that for a minute. Let's leave it alone for a minute. Let's finish. Let's get to the network layer and the transport layer. We'll come back to pinging. Okay. So understand what is routing. Routing is the process of moving data, right, between networks. You have the router, it's a device. The purpose of that device is what? To route. Okay. If you need to get out of your house, right, the router has a routing table. How to get to the router? That's inside your network, your LAN 1, you have that. The router is giving you the ability to move data between networks. We are moving data between networks. Okay. Now, if we are switching, which is what we have a switch over here, right? Let's finish all of that before we come to your pinging. We have a switch over here. So switches are just moving the data. Are they moving the data between networks? No. They are moving the data within networks. So there is a word called between, because you can see this is in between two. Between, right? This is between, router is between two networks. And this one is within the network. Switching helps you move within the network. So that is the primary purpose of the switch, is that if you are communicating within your own network, right, within a data center, within a LAN, right, it is going to allow you to switch between a LAN, right? So you have many other devices that you have. Now, layer 3 is the IP addresses, end-to-end delivery, right? And your layer 2 is providing you, let's go here. Your network is going end-to-end. Okay. Now, you have the physical layer, right? We have already discussed the physical layer, which is transporting the bits, taking the data, right? Layer 2 is your data link layer, which is hop to hop, MAC addresses and switches, right? MAC addresses and switches, which is what Wale was talking about, right? That is why we call these layer 2 devices. Sorry, that should not be the word. That is why these are called layer 2. Switches are considered layer 2 devices, right? Now we have switches, right? And now we go to layer 3. Layer 3 is the network layer, which is the end-to-end layer, where you have the routers and any device with an IP address. That's why we call it logical, because you're going to ask me the question, well, the router is kind of doing a layer 2 job. Why do we call it a layer 3? And the switch, okay, I can understand it being doing a layer 2 job, but it's kind of also routing within a network. It could be considered L3. That's why in today's modern technology, you have L2, L3 switches, and you have routers that can also do what L2 does in it, because it's a logical layer. But in sort of keeping things simple for shooting purposes, you don't need to get into the device technology, what they can do, and how they've enhanced the technology. You just need to keep to the simple end of troubleshooting. Okay, so we are basically taking data. We have a client IP and we have a destination IP, and we basically get to the end and we get the data to the end, right? Now, we have the TCP IP model, which we are not going to go into at the moment. But we're going to talk about one thing really important that I have put down in my notes before finishing this class, right? And that is, ladies and gentlemen, that is going to be your layer 4. Your layer 4 is very important, right? So, so we have the IP addresses we need for end-to-end from the network part of the business. We also have the routers that are situated in here. That's not supposed to be that. I'm cutting out some things. Let me see. Protocol. Okay, we have done the hop to hop, right? We've done end-to-end. And now we want to talk about something very important, which is the transport layer. All right. Guys, you can take a picture of this. If you don't want to take a picture of this, I'm about to clear this out and we'll jump into the last part. Any questions at this time? Any questions at this time? Up to layer 2. Layer 2, layer 3, are we clear?
Yes, clear.
Okay. Now, let me clear all the drawings. So we have on this side, we have, I'm not going to, orange, I don't want to clear, we can do that 1 second. Clear the drawing. You have one machine. What does the machine have? 2.2, I'm just going to randomly 2.2. It has an IP. Okay. It has an IP. The machine has a web page, right? www.bank.com. And this is something I've done from the work I do. And you are reaching the bank's web page, right? www.bank. We're going to talk about this next week because we are going to host our first website next week, ladies and gentlemen. So, and we will talk about HTTP at that time. So you have this bank site is secure HTTPS, right? And this HTTPS So we have 1, 2, 3, 4 transport layer, right? And we have the networking layer. And we had the data link layer, data link, where the physical, right? In the data link address, we had MAC addressing. MAC addressing, that's the word you need to remember. So you use this MAC addressing system to reach that. Here you had the IP addresses, okay? Now we come to the most important part. Why is layer 4, the transport layer, very important to us, right? So we are sending out, right? We are sending out some kind of, the data. We need to get the blue. Thank you for your patience, everybody. So we have data that we are putting out. It could be a simple thing as a request, right? So we have a source, right? And we have a destination. Okay, we have a source and we have a destination for this data. Now the IP of this machine is 1.1.1.1. Okay, and I have another machine over here, right? That has an IP of 3.3.3. I'm just giving randomly IP, right? And this is, let's say, your Zoom server, right? Or chat server or WhatsApp server, whatever you got, right? And this one is running. So this is running TCP, right? And this TCP and 40. So we're going to try and understand some of these things. And now you're running on the Zoom servers, you're running UDP, and you are running 1667. Very important. Very important. Anybody who teaches DevOps and doesn't teach this, they're misleading you. They're misleading you because they're assuming you already know some of this, and they're stripping you away from this, not teaching you some real important reasons of how today's modern uh, designs are working. Okay, so this is the final journey we are going to do today in understanding this. Okay, so what is the source? Anybody, give me the source IP. I've given the IP here. What is the source IP? What is the source IP? 1.1.1.1, right? And I want to go ahead and reach the bank page. So what is the IP of the bank page? Destination.
2.2.2.
Thank you. Right? What layer are we discussing this in? This is all in layer 2. Transport, yeah.
Transport.
Layer 3.
4.
IP addresses, layer 3. Yes?
Yep.
Now we are clear. Now we are clear finally. Now there is another thing with this IP addresses. On every web page you're going to load, right? You're going to have, for example, 9999. Okay? And the port over here is 40. This, ladies and gentlemen, is layer 4. Layer 3 cannot work without layer 4. So they will go in conjunction. And layer 2 we don't worry about that because that is the MAC addressing part of the business, which ensures that this data is moving 100%, hopping through the different devices. Now we're only talking about end to end. So a part of L3 is related to L2, and a part of L3 is related to L4. That's why this is a stack. You hear this stack, okay? This is your network stack, okay? You're stacking it up. It's somewhere linked, it is linked. So now we have an IP address that is in place, right? So layer 4, here we said that this one is responsible for end to end. Yes? If anybody asks you this question in your life, what does network layer do? It provides you end-to-end connectivity. It's responsible to ensure that your data can make it end-to-end. You have to answer this question in your evaluation to me. What does the network layer do? It ensures that we can communicate end-to-end. However you want to learn it, then say it to me. I don't care. But that is what you got to prove and demonstrate to me. That network layer works end-to-end, and end-to-end, there are only two things you need. IP addresses end-to-end. One of the things you need end-to-end, right? Then why should we not call the transport layer end-to-end? Mr. Nadeem, are you trying to confuse us? What are we trying to say here? The MAC addressing handles hop to hop. Hop to hop. You know that one very well now. Mac to Mac. Big Mac to Big Mac. You're traveling and eating McDonald's on your way. You know you love it. I love it. I can and not here. It's not halal. So, right? End to end. Guys, end to end. Now, so what the heck is a transport layer? Nadeem Saab, you are cheating us. If this is end to end, then what is transport? Isn't that also end to end? Well, ladies and gentlemen, we have an addressing over here, which is being done through ports. You see the word addressing, address, MAC address. So the transport layer uses an addressing also called port address, right? This is a port address. And this is called service to service. Remember that. You're not going to find it anywhere. And nobody teaching this at all to remove the confusion. And I'll explain this to you. So we have this going on, right? Layer 4, transport, the transport layer, service to service. Okay. So I got something interesting for all of you. So we're going to do this. You got some data over here called data 1. You got some data over here called data 2. You got some data here called data 3. Right? And you got some data going on called data 4. So this is where data 3 has to come. This is where data 2 has to come. Watch this carefully. Okay. I got data in a pipeline, right? I got a pipeline of data because when you're sitting on this machine, you have one browser open, you're looking at GitHub, you're looking at your bank, you're playing a video game, you're sitting on Zoom. You have multiple data that is coming, right? And we will talk about this data package and all that. It's not important. We're going to talk about the data. So all of this is data that is coming through. And each of this data has a source and a destination. Each of this has a source and a destination. So the source and destination for data 3, right? I'm going to put it up here, is this is the source. And sorry, so the source is white. So this is the source. And this is the destination. Right? We're getting to this destination. That's the destination. That this data, which we are calling here, this is data 3. So data 3, my ladies and gentlemen, it needs an IP address. It's going to find the IP address, right? But on top of finding that IP address, it's going to need to be able to discern where it needs to go, right? So if it is related to a web page, right? It needs to come in here. It needs to come in here. And it needs to, because we say HTTP is an application layer. So we're not talking about this right now, right? That's not what we're talking about, right? We're only talking about this layer over here. So you have to add on a port number, right? You have to port. What is the port number for SSH, right? You want to come into a machine, right? I'll put the purple here. Purple machine.
22.
Yeah, 4.4.4.4, right? And you're going to come in and do SSH, right? But to SSH is a layer 7. Don't worry about that. So we're not talking about that yet right now. But you need to be able to, this has to be on port 22. Because in order for that application, so it's a service. Remember, we said we have a SSHD daemon. When we do firewalls next week, we're going to talk about the firewall has enabled SSH service, right? So SSH service. That is why the transport there is a service to service, because the port is important. There is a port over here, port 22, right? So if you are not sending this IP to the right port, you're not going to get there. Or if you do put port 22 over here, right? When this data comes all the way to the end, right? When it comes to the end, if it's 22, this data is making it over here to this port. Okay. So the layer 4 or the transport layer provides you a port, a way to come into that machine where you're going to find a particular service. In the world of IT, there are multiple services running. You have on port 40 HTTP. You have, so how many ports are there today in Linux in the world of IT? You have port 0 and you have 6,000, I think 65,535
5,000.
ports or something like that. You can check, Google it, right? Do we want this to be a secure connection? Or are we going into an unsecure connection? Okay. If you are looking at data reliability, if you don't want to lose it, you want this data to be as it is, right? Early on, somebody said, I hear background noise. I cannot hear you. Do we care about losing the data? I said, oh, can you hear me now? the data is back again. So here we don't care about the data. That's why it is UDP. And here we do care about the data. We want to make sure we are able to connect to that. We need to be able to stay in that session. That is why this is going to be 7, 6, 5. You need to be logged in once you SSH, and then you have the application as we're not talking about now. So that is data we want to make sure it gets to that point. Here we don't care about the data. So ladies and gentlemen, this is what I wanted to share with you today. And that is everything we have covered in terms of troubleshooting. And when we start troubleshooting, we'll have 30 minutes Monday, Tuesday, Wednesday, Thursday, Friday. Next, coming up tomorrow, I'm going to start talking about how to troubleshoot hop to hop, how to go into ping, and I'll explain that. And when we do the transport layer, when we have ports, right? So when you're looking at websites, we need to have an L4. So we have an L4 layer. So every website you check today, it has your host IP address, and it has a port attached to it. When you are typing HTTPS, and we are not going into that right now, and you are going to, when you say HTTPS, right away, an address like Google address 8.8.8 is connected to port 443. That's how this makes it to the end. So here you have your IP, and here you have your port. That is layer 3, and that's layer 4.
And
Are we clear?
this TCP is also a secure data?
Yes, secure है. TCP is secure.
Okay.
हम TCP UDP की बात करेंगे. We will talk about it later on.
Okay.
So the things we need to talk about is ping, UDP, TCP. Okay, we know that this is secure. Yes, sir. Go ahead. Go ahead. I'm listening. So let me do this. Let me just do one last part, and then we can call it a night. Clear all the drawing. Ladies and gentlemen, just for the benefit of early on, we have talked about data all along today. We have data, right? Now we said that data is coming from which 3 layers? 7, 6, and 5. Application layer, presentation layer, and session layer. This is data. Data is put together. Anybody who can tell me an application, example of an application?
Sapati?
Zoom.
Give me an example of an application you use every day.
Putty application we are using or Chrome browser.
Good. Anything else that is very common? WhatsApp.
WhatsApp.
What's up, sir?
Yeah, WhatsApp, the application you're using. Now, that's layer 7. When you open the layer 7, when you open the WhatsApp, it tells you your data is encrypted. It is safe.
Yes.
That is layer 6. And then if you have to log in, session, that is layer 5. So this is all contained in this data. This right here, ladies and gentlemen, don't forget, this right here is all of this put together is your data. And this data is all in binaries.
0, 1.
Yep, inside. You don't care about this data. That's why people say, we don't care about the layer. Now, once this data moves down, right, and it comes to layer number 4, layer 4, we say this is the transport layer. Transport. So what does the transport layer do, right? The transport layer decides something for you, okay? It says, let me put it this way. Let me put it this way for your ease understanding for all of you. Okay. Uh, uh, bear with me. Just give me 10 minutes. And that's gonna really change the way you look at things. Okay. So you have uh, application. Okay. Then you have presentation. Right. What's the next one? Trans. What is the next one? Session.
Transport.
Right.
Session.
Session.
Then
Right.
transport.
All right. So we have 7. We have 6. We have 5. These 2 layers together, right? These 3 together are giving us what we are looking for as our data, right? This is
Data.
data is here. All our data is all here. Right here. Don't forget this. So this is combination of this. You got the data. You got a session layer, login, encryption, WhatsApp. Okay, all good. So now we have coming down to 4. Okay, layer 4, transport. What happens in the transport layer, ladies and gentlemen? In the transport layer, we've already said the transport layer is
Ports.
service,
To service.
service to service, service to service, right? And in this service to service, it is giving you TCP. I'm summarizing this for you. UDP, TCP, UDP ports. Some ports are UDP ports, some ports are TCP ports. Then on the left-hand side of this, we have this data now, this particular data now has got something attached to it, TCP, right? The data is still there. The data is still there. Then we come to, let me just put all the layers here so we can conclude this class. I know you are tired. 4, 5, sorry. So I'll do the summary. You can take a picture of this in your camera. The reason I'm putting this picture is it'll allow you to 3, 4, 6, 5, 4, 3, 2, 1. Got it. Beautiful, beautiful. Then I'm just gonna put a table for your summary over here, which is end to end. We have hop to hop.
Oh,
Okay. And then we have bits, 0110 bits, right? These are transporting bits out all the way out. We have here IP address. We have MAC address. And that's why we say over here you got routers. And now you've got hosts, your machines, right? Routers and hosts, which is IP. Every host is and then you have switches. Right? And if I came up here, I'll call this devices. This is the category of devices. Okay. And we also have, ladies and gentlemen, firewalls in this layer. We're going to talk about firewalls, but I'm going to leave that out for now until I teach you firewalls. I can erase this. Okay. Well, it is what it is. Then we have cables, fiber optics, and all that other fancy stuff, right? So now we have got this, and now we have the transport layer, we have the network layer, and we have the data link layer. You take a picture at the end, and you will not ever forget this. One picture is all you need to know, and it'll bring back everything to your memory, right? So when you go down to the next layer, right, it becomes like this, right? You already have the TCP header. Now you're going to put in the IP addresses here, okay, right? And inside here, you have a TCP header also, and you have the data as well. But the reason I have put it this way, a lot of people, okay, I don't know what happened there. Okay, I'll draw that in the end, but let's just finish this. So you have, you're coming down here, you have, this now becomes a data, and you have the IP, okay? And then you have become all of that, when you come to this layer, that's connected to that layer, that's connected to that layer. And then you have your MAC addresses here, right? You have your MAC addresses here. So you do have the TCP, you do have your TCP, the port number, and the IP that's over here, but you also have on top of that your MAC address, where it is going, the hop. And as this data moves on from hop to hop, this data gets removed, a new data is put in there. And this is, so how much of this data you want it to be secure is defined by TCP and the port it's going on, right? So ladies and gentlemen, that is how data is coming down. There's one last thing that you need to know about this data is that you have this part has been, this whole part is called a segment, and you don't need to worry about this. And the segment then becomes a packet, and the packet becomes a frame. And so the last thing that this thing sees, this is a frame, and then you have a packet, which is over here. So don't worry about that. When we do, we do Wireshark, right? When we do packet tracing, TCP dump, right? So people you'll hear in the IT world talk about packets. How many packets did we lose? When we do that IP ping, right, end to end, packets are, say, did you get 100%? Was it 100% when you were pinging it? Was it able to send it 100% come back? And it was giving you that it's fine. So when we get to packets, when we get into IP, we'll talk about that. For now, I don't want to bring that up in between this discussion. So we'll leave this alone. That was a question I think Akhtar you had early on. Any questions at this time, ladies and gentlemen? And if you have, anybody has any question?
Awesome.
Right? Hop to hop, right? And here you have switches. You have routers, right? You have cables. And you have MAC addresses here. And you have IP address over here. Right. Any questions at this time, ladies and gentlemen? No questions? Everybody is clear? सब लोगों को साफ है? Everybody is clear on this?
Yes, clear.
Yes, sir.
Yes, clear.
And just to let you guys know, one last thing is that when we talk about ARP, that ARP thing that I've talked about, which you don't need to worry about too much, you can read on it, it happens here. A R P. It is like between 3 and 2, 2 and 3. Layer 3, layer 2. That's where ARP sits. All right. If you guys hopefully can watch this, watch your pictures you have taken in the camera. Please walk around. One of the rules of life is repeat this stuff. Go through this. You don't need to memorize the layers. What you need to memorize is 765 puts the data together, and then service to service is provided by the ports. End to end, IP addressing is done by layer 3, networking. Hop to hop is done. So I think layer 1 and 2 are straightforward. I would focus my energy in memorizing 4 and 3. Just focus on memorizing what 3 and 4 does. And if you can do that, walking around, hard coded in your memory, and you will become you want to become an SME. You want to be able to stop someone and teach them the same stuff. You don't want to have some kind of superficial knowledge. Okay, let's memorize 765. The application is in pizza. Don't memorize garbage. They're teaching this on YouTube. How to memorize APS, TNDP. Listen, a subject matter expert doesn't memorize stuff that is of no use. A subject matter expert, this is a subject matter expert slide in front of you. I'm going to put all this in a slideshow. You guys will have secure, good slides. Give me a couple of days to update my slides. I'll send them out to you. But rather than reading the slide, Imam Ghazali is a very popular person, and he was going on a journey and he lost his books. The robber, the thief came, he said, oh, my book. He said, oh, you are Ghazali. He said, yeah. He said, that's interesting that. He said, what kind of a person are you that carries your books around and you don't secure the knowledge in your heart and in your mind? That is why Imam Ghazali is considered an SME in his subject. He was a subject matter expert. He took it to memory. You have to memorize this stuff, ladies and gentlemen. And let me end this by saying one last thing. Okay, I'm gonna